Fine. Write the heading properties of inverse Laplace transform. Write fast. Properties of inverse Laplace transform. Are you able to see this word? Is it clear? Okay, fine. See, properties of inverse Laplace transform. Already we have discussed many property in Laplace transform. First property, linearity property. If you are able to write with me, otherwise I will send the notes also. Okay, please listen. So what is the linearity property is L inverse of A into f of s plus b g of s is equal to a f of t plus b g of t. It is linearity property. Second property is first shifting property. First shifting property. The first shifting property, if L inverse of f of s equal to f of t, then L inverse of f of s minus a equal to e power a t f of t. See, for example, one simple example I can give here. L inverse of s minus 2 divided by s square minus 4s plus 13. L inverse of s minus 2 divided by s square minus 4s plus 13. Now listen, we have to change in terms of s minus a format. So how to change this? See the denominator. This can be written as L inverse of s minus 2 divided by s square minus 4s plus 13 is there, na? Plus 13 can be written as plus 4 plus 9. Okay, listen, this can be written as L inverse of s minus 2 divided by s square minus 4s plus 4 is there, na? Put the bracket here. This is s minus 2 whole square and then plus 9 is there, na? This can be written as 3 square. Now, using this property here, what is f of s minus a? E power a t f of t. Here in the place of s minus a format, na, that means s minus 2 format. Therefore here a equal to 2. So in case if a equal to 2 here, in case if it is a equal to 2 here, it can be written as e power 2t L inverse of s can be written as sorry, s minus 2 can be written as only s, because we are multiple with e power 2t here, s divided by, once again down, the denominator s minus 2 is there na, that s minus 2 can be written as s. So s square plus 3 square. What is the formula for s divided by s square plus 3 square? What is the formula for s divided by s square plus 3 square? Cos 3t. So e power 2t cos 3t is the answer for this. E power 2t cos 3t is the answer. Fine. Similarly, third property is there, that is second shifting property. Second shifting property. Just now I have written that second shifting property of Laplace transform. The second shifting property of inverse Laplace transform is, if L inverse of f of s equal to f of t, then L inverse of e power minus as f of s, e power minus as f of s, which is equal to f of t minus a, where t greater than a, 0 when t is less than a. Fine. See, for example, find L inverse of e power minus pi s by 6, e power minus pi s by 6 divided by s square plus 1. See, it is in the format of e power minus as f of s format. What is a here? In the problem, what is a? A is pi by 6 na. So therefore it can be written as, that is equal to f of t minus a. F of t, what is f of t here? 1 by s square plus 1 na, sin t is f of t. Therefore this can be written as sin t minus pi by 6 when t greater than pi by 6, otherwise if it is 0 when t less than pi by 6. Actually this type of problems are MCQ problems. Second shifting property. Next one is change of scale property. Fourth property. First one is linearity property. Second one is first shifting property. Third one is second shifting property. The fourth one is change of scale property. Change of scale property. In the change of scale property, the statement is, if L inverse of f of s equal to f of t, then L inverse of f of as, capital F, 1 by a, f of t by a. For example, L inverse of 3s divided by 3s whole square plus 16. Okay, listen, see that L inverse of f of as, where as see 3s. Okay, therefore a is 3 here. So we can write this as 1 by 3 cos in the place of t, 4t by 3. Then fifth property is inverse Laplace transform of derivatives. Inverse Laplace transform of derivatives. Inverse Laplace transform of derivative is if L inverse of f of s equal to f of t, then L inverse of fn of s, fn of f power n means L inverse of d power n by ds power n f of s, which is equal to minus 1 whole power n t power n into f of t. Okay, fine. So here next one property is inverse Laplace transform of integral. Inverse Laplace transform of integral is if L inverse of f of s equal to f of t, then L inverse of, this property is more important, L inverse of integral over s to infinity f of u du equal to f of t by t. Seventh property, multiplication by s, that is if L inverse of f of s equal to f of t, then L inverse of s into f of s is equal to f dash of t. For example, in case the given problem is L inverse of s by s square plus 1, case L inverse of s by s square plus 1, then listen man, L inverse of s by s square plus 1, then it can be written as L inverse of s into f of s. So what is f of s here? What is f of s here? L inverse of s into f of s is 1 by s square plus 1. Okay, 1 by s square plus 1 is L inverse of 1 by s square plus 1 is, what is 1 by s square plus 1? L inverse. Why you are seeing note? It is simple only na. Are yaar. Sin t, but f dash of t na, d by dt of sin t. d by dt of sin t. Okay, what is d by dt of sin t? It is cos t. You know, directly we can write s by s square plus 1 is cos t only. But for example, I am writing, in case if it is multiple with s, then we have to differentiate one time. Okay, then in case multiplication of by s, okay, divide by s means, in case if it is divide by s, division by s. Division by s. Division by s is if L inverse of f of s equal to f of t, then L inverse of f of s by s, which is equal to integral over 0 to t f of, already t is there na, so it will not come. So here f of u tu will come here, f of u du will come. Otherwise it also can be written as integral over 0 to t f of t can be written as L inverse of f of s du. Okay, so these are the 8 properties are important. Even we can write one example. For example, L inverse of 4 divided by s into s square plus 16. 4 divided by s into s square plus 16. Actually, how can we do this one? In case if you are not able to know that formula, you have to do by using the partial fraction method. You do by the partial fraction method. A by s plus bs plus c divided by s square plus 16. We have to do. Otherwise, we can do this as L inverse of f of s by s. We can do f of s by s. So how can we write this? That is equal to L inverse of f of s is what? Here 4 divided by s square plus 16 whole divided by s. So this can be written as f of s by s. So here that is equal to integral over 0 to t L inverse of f of s, that means f of t. F of t is what here? F of u sin 4u du. Then if you are integrate this, what will you get? Sin 4u formula is sin 4u, integration of sin 4u is minus cos 4u by 4 from 0 to t. So you will get the answer is 1 by 4 1 minus cos 4t. So these are the properties are important. Totally 8 properties are there. Linearity property, first shifting property, second shifting property, change of scale property, and then inverse Laplace transform of derivative, inverse Laplace transform of integral, and then if the inverse Laplace transform multiple by s, inverse Laplace transform division by s. So these are the 8 properties are there. Now we will see that very important one property, convolution theorem for, write everyone, convolution theorem for, put 2 important sign compulsory, one problem will come based on this convolution theorem. Convolution theorem for inverse Laplace transform. Just now I have written now, what is the convolution theorem for Laplace transform? What is the convolution theorem for Laplace transform? we know that what is the Laplace transform convolution theorem? Laplace transform of f of t star g of t equal to f of s multiplication of g of s. So what will you do is taking the inverse Laplace on that side, then what will you get? F of t star g of t equal to L inverse of f of s dot g of s. So here we can see that L inverse of f of s dot g of s is there na. So what is the formula here? By the definition of the convolution, what is the definition of convolution? I have given na. You can see the formula. What is the definition of convolution? I have given the formula. What is the definition of convolution? F of t star g of t, integration of 0 to t f of u into g of t minus u du. Okay, fine. This is the formula. This formula is important. L inverse of f of s dot g of s equal to 0 to t f of u g of t minus u du. Problems using convolution theorem. Problems using convolution theorem. Problems using convolution theorem. Write down. Problems using convolution theorem. Find. Are able to see that? Find inverse Laplace transform of s divided by s square plus a square whole square. The same problem repeats many times. S divided by s square plus a square whole square. Write the solution for this. Find inverse Laplace transform of s by s square plus a square whole square. Okay, fine. Now write that. What is the problem, man? அவனை வெளில அமிச்சிட்டு தனியாக சிரிச்சிட்டு வர சொல்ல அவனை நான் ஏப்ட்டு அனுப்பான் எந்திரி இவனுக்கு பக்கத்தில் அவனை ஏப்ட்டு எந்திரி அவன் நோட் எடுத்துட்டு வெளியில் போயிட்டு நோட் எடுத்துக்க சொல்ல அவனை ஸ்டாண்டப் மேன் வெளில வர சொல்ல முதல்ல ஆப்ஷன் போட்டு விடுவோம் அவருக்கு படிப்பு. I am doing that problem is very seriously. Just you are stay there and then you are laughing there, na? Huh? Am I joking there? Huh? Come, you come and write here. Come and do that. Not able to do, na? Able to do or not? I can disconnect all the things. You can continue that one. Complete this. Then go and stand there last. Idiot fellow. Then write here L inverse of what is given here. What is the given function? S divided by s square plus a square whole square. See, this can be written as L inverse of s divided by s square plus a square. Any others want to go outside? 1 divided by s square plus a square. Now listen. Here I split the function into two functions. What is the reason? What is the reason? See that convolution theorem definition. L inverse of f of s into g of s. Listen, in case only s by s square plus a square is there, s divided by s square plus a square is there, simply we can write that cos at. Formula is cos at, we can write that. In case s square plus a square whole square is there, at the time you have to split that function. So how to split the function here? It is in the format of f of s into g of s. What is f of s here? S divided by s square plus a square. G of s is 1 by s square plus a square. Okay, fine. Now what is by the formula for convolution? By convolution property, write down. By convolution theorem or convolution property, by convolution theorem, L inverse of f of s dot g of s equal to f of t star g of t. It is a convolution theorem formula. It is a convolution theorem formula. So, what is f of s here? F of s is s by s square plus a square. That implies, what is f of t? Cos at. Cos at. G of s is 1 by s square plus a square. What is g of t? Sin at by a. Be carefully write this formula. When you are writing that 1 by s square plus a square, many of them are doing the mistake in this step only. They are writing simply sin at. Actually it should be sin at by a. Okay, fine. In the next step, you can write that L inverse of f of s dot g of s, you can write this as L inverse of s divided by s square plus a square whole square. That is equal to what? F of t star g of t. Now what is f of t here? What is f of t? Cos at star g of t is what? Sin at by a. Fine. Now listen. By the definition of convolution, what is the convolution definition? F of t star g of t, integral over 0 to t, integral over 0 to t, f of u is what here? Cos au, g of t minus u na? Oh, then how can you write? Sin of a into t minus u divided by a. I can take that by a outside, 1 by a, and then du here. Okay, fine. Now I am asking that very basic question. What is sin a cos b or cos a sin b? Cos a sin b formula. Tell me. Arey, you are laughing na there. What is the formula for cos a sin b? Tell me the answer. You know everything na? Genius fellows. Looking like genius, then not knowing anything mean what? 2 times of 2 times of. Arey yaar. See, there are 4 multiplication formulas are there. Sin a cos b, cos a sin b, cos a cos b, sin a sin b. Okay, listen. First sin a cos b, sin a cos b, sin a cos b, 1 by 2. Write down sin of a plus b plus sin of a minus b. First formula cos a sin b, 1 by 2 sin of a plus b minus sin of a minus b. Then cos a cos b, cos a cos b, 1 by 2 cos of a plus b plus cos of a minus b. Then sin a sin b, 1 by 2 cos of a minus b minus cos of a plus b. Please don't forget these 4 formulas because we will use these 4 formulas in the Laplace transform. Okay, fine. Then how can we write this integration now? Integration becomes you write as note this one. Okay, now continuation of the problem. Integration becomes what? 1 by a integral over 0 to t. Okay, 1 by 2. Either you can take cos a sin b or sin a cos b, whatever it may be. In case if you take cos a sin b, mean what is a here, what is b here? A is au, b is a into t minus u. Then what is the value? 1 by 2. Cos a sin b, if you are okay, fine. Cos a sin b mean, then what is the value? Sin of au. Then here a plus b na u get cancel. Okay, sin at, fine. Then plus cos a minus sin of a into u, 2u minus t na, 2u minus t, is it not? Du. Okay, fine. Now 1 by a, take it to outside. Integration of sin at is wrong. Anyone? Anyone? Listen, you are integrate with respect to u. Sin at is there na, therefore it is constant. Sin at, integration of u is u, 0 to t minus sin a into 2u minus t minus cos. Sign of integration is minus cos na, minus plus cos of a into 2u minus t divided by 2, a will come from 0 to t. So what you get? 1 by 2a sin at, and then if you are substituting t here, t sin at, is it not? And then lower limit is 0 plus what happened to this second term? Substituting t there, 2t minus t is cos a minus cos a, 0, substitute 0, second one. What do you get? Cos of minus at. Cos of minus theta is what? Cos of minus theta? Cos theta only. So cos at once again. Divided by 2a. So cos at get cancelled. What is the answer for this? T sin AT divided by 2A. What is the left hand side? Laplace inverse of S by S square plus A square whole square. What is the answer for this? Laplace inverse of S by S square plus A square whole square equal to T sin AT by 2A. So for this convolution, you should know that convolution theorem. You should know the convolution theorem and then basic trigonometric formulas. Okay na? Find L inverse of S square divided by S square plus A square whole square. Find L inverse of S square divided by S square plus A square whole square. It is the second problem. This one. It is problem number 2. Actually, problem number 3 is there. One more. Fine. For L inverse of S square plus S square divided by S square plus A square whole square, then how can we solve this? What is given here? Given L inverse of S square divided by S square plus A square whole square. See, already we have written S by S square plus A square whole square. Now S square is given. Then how can we write this? L inverse of S divided by S square plus A square, S divided by S square plus A square. The same problem can be given as L inverse of S square divided by S square plus A square, S square plus B square. Sometimes may be given like that. Only A and B is changing. So here what is, this is in the format of f of s into g of s. What is f of s here? S divided by s square plus a square. G of s is s divided by, here whole square is not there, na? Second one, whole square is not there. So s divided by s square plus a square. Then what is f of t? Cos at. G of t is once again cos at1. Therefore L inverse of s square divided by s square plus a square whole square equal to cos at star once again cos at. Convert into integral. Integral over 0 to t cos au into cos t minus u du, because f of u g of t minus u du na formula. Then what is cos a cos b formula? Cos a cos b formula 1 by 2 integral over 0 to t, taking 1 by 2 outside, cos of cos at plus cos a of a minus b na? What a minus b? 2u minus t, yeah? 2u minus t na? Cos a plus b is au. Oh, here at is there na? At minus au. So au get cancel. Cos of at will come. a plus b, and then a minus b is au minus at plus au. So 2au minus at, a outside, 2u minus t du. Okay, fine. Then integrate this 1 by 2. Cos at is constant here, so cos at u 0 to t plus cos at integration is sin a into tu minus t divided by 2a from 0 to t, from 0 to t. Okay, so that is equal to 1 by 2 t cos at, t cos at plus, substituting t there, 2t minus t sin at minus 0, substituting 0, sin of minus t divided by 2a. So what you get? 1 by 2 t cos at plus sin at, sin of minus t, here a should be there, na? Sin of minus t minus theta minus sin theta, already minus is there outside, minus minus plus, so 2 sin at divided by 2a. So this 2 get cancelled. Therefore this can be written as 1 by 2a, 1 by 2a at cos at plus sin at. What is the left hand side? L inverse of s square divided by s square plus a square whole square. Okay, what is time? My cell phone. In case L inverse of 1 by s square plus a square whole square is there, 1 by s square plus a square whole square is there. At that time, how can you solve this? This can be written as L inverse of 1 by s square plus a square, 1 by s square plus a square. So what is f of s here? F of s 1 by s square plus a square. So what is f of t here? Sin at by a. Similarly, g of s is 1 by s square plus a square. So what is g of t here? Once again, sin at by a. So therefore L inverse of 1 by s square plus a square whole square, which is equal to 1 by a square sin at star sin at. Is it not? Convert to this integration, 1 by a square integral over 0 to t sin au into sin a into t minus u du. Sin A, sin B formula. Sin AU, sin of A into T minus U, that is equal to 1 by 2 cos of A minus B. A minus B is AU minus AT plus AU. That means cos of 2 cos A into 2U minus T, minus cos A plus B. A plus B is AU get cancelled, AT will come. Okay. So this is the formula. Apply in this formula, we will get that 1 by A square integral over 0 to T, taking 2 outside, 1 by 2A square. So cos of 2U minus T, and then minus cos AT dt, that is equal to 1 by 2A square. What is cos 2U minus T? Cos of integration, sin na? Sin 2U minus T, A should be there outside, here also A should be there, A outside should be there. 2U minus T divided by 2A minus cos AT, here you have to write U, it is not dt, du na, U from 0 to T, here also from 0 to T. If you substituting 0 to T here, what you get? 1 by 2A square, substituting T here, 2T minus T, sin AT by 2A. No need to substitute lower limit. No. So lower limit 0 is there, na? Minus sin, if you substituting sin of minus T plus, it will be plus. So sin AT by 2A minus cos AT into T, you have to multiple. So what is the answer for this finally? What is the answer for this? 2 get cancelled here. 1 by 2A square. 1 by 2A square sin AT by A minus T cos AT. Okay. So final answer is Laplace inverse of 1 by S square plus A square whole square equal to 1 by 2A cube sin AT minus AT cos AT. So what are the 3 important results we will use in that problem? These 3 results will use in the problem. This come as a problem, and then these 3 results will come into the problem. In case if you are not able to remember these 3 formulas, you have to do fully again. Because you are not able to remember this formula, only 3 formulas are there. S by S square plus A square whole square, S square divided by S square plus A square whole square, 1 by S square plus A square whole square. 3 formulas are there. All the 3 formulas are very, very important. Any one of the problem will come to that examination compulsory. Okay.